So it says that T2 is 15 and T7 is 3645, and we want an explicit formula for Tn. So generally, a explicit formula in a geometric sequence is this is the formula for it, right? For an explicit formula, if you want to write it explicitly, is Tn equals AR to the power of n minus 1. So since we're given T2, so that subscript 2 and that subscript 7 is the n that goes in these two places. So we can say that in this case, right, that T2 subscript AR n, the subscript, goes over here. So 2 minus 1 is equal to, since they already gave it that T2 equals 15, we know that this entire thing has to equal 15, right? T2 has to equal 15 from this formula. And they also gave us the another one, T7 equals this, right? So we can say the same thing. So AR subscript 7 minus 1 equals 3645. Okay, so what you really want to do now is we can simplify all of this, right? So this becomes we can say that, well, okay, 2 minus 1 is 1, so that's basically to the power of 1. So AR to the power of 1, we don't have to write that, equals 15, right? And over here we can say that AR 7 minus 1, which is 6, AR to the 6 equals 3645. And generally now we want to basically make a ratio for both of these. So we can say that we can do this basically. So we can put this one on top and this one on bottom, make a ratio. So we get AR to the 6 over AR to the power of 1. We don't have to write that. The A's are gonna cancel and the R's are gonna subtract. So it's gonna become R to the power of 5, because this is invisible 1. Subtraction rule is that since this is cancelled, this becomes R to the 6 minus 1, right? And you get R to the 5. You subtract the exponents if they have the same base, which is R in this case. So R to the 5 equals, well, we know AR to the 6 was 3645 over AR, which is 15. So another way you could really write this, if that didn't make sense, is AR to the 6 over AR. Well, AR to the 6 equals 3645 and AR equals 15, right? And this, I believe, is equal to 243. And this equals R5, right? The algebra that plays out, R to the 5. So we want to get a general term for R. So we don't want this power. So to solve for R, so R to the power of 5 equals 243. We can take the fifth root and get the R alone. So R equals the fifth root of 243. And I believe that is, 3. So now we have that, we can say that since we know that over here, where was it? Over here. Yeah, over here, AR equals 15. We found the R value. We just need to find that A value to plug in over here. So we can say that AR equals 15. We found R. So we can say that A times 3 equals 15. And that means that A equals 5. Because if you solve for A, you divide by 3. And 15 divided by 3 is 5. And that's your A value. So, and that's your R value, right? And basically that's all you really need. And now you have the formula for Tn. Tn equals a, which is 5, times, you can either put it like this, which I would prefer, to the power of n minus 1, right? N is any term you're given. And of course, you can also just write it like 5 times 3 n to the n minus 1. And that's your answer right there. This is an explicit way of writing it, by the way. Yeah.